All right, here we go. We're going to talk about sections 4.5 and 4.6. Basically, it's on congruent triangles. We're going to describe, first of all, congruent triangles. Before I get started, I want to make sure that you already wrote down part of the notes. If you didn't, you need to go back to my website and check that out, because I already showed you the notes that I wanted you to have pre-written before you started the video. I'm really trying hard to make these videos as short as possible. Alright, so I want to explain some of these things. I've got a highlighter in my hand. So if you need to find a highlighter maybe to follow along, then that would probably be great. The first thing is how to use triangles that are congruent. I want you to notice at the top it says when triangles are congruent. In other words, we know for sure that triangles are congruent. If you do know that they're congruent, then you're going to use CPCTC right here to prove that any pair of corresponding parts are congruent. So when the triangles are given, you're given that they're congruent, you're going to use CPCTC to show the parts are congruent. Let's talk about what an isosceles triangle is first, before we get too far into that. Right? The isosceles triangle is a triangle with at least two congruent sides, and we've talked about that before. I do want to make sure that you have all the parts labeled. Remember we talked about this in class, that the two congruent sides are actually called legs. So this is a leg and this is a leg. And then the angles down here at the base are literally called, these are called base angles. Base angles here and here. Alright, so you've got 1, 2 base angles. Now, the base angle theorem of an isosceles triangle states that if two sides of a triangle are congruent, then the angles opposite them are congruent. So, let's prove that. Basically what we're going to try to prove is if we have isosceles triangle, then the angles opposite them are congruent, just like this. So we'll start out with triangle ABC, and we know that triangle ABC, we know that AB is congruent to AC. Why? Because that is an isosceles triangle. We're going to prove that angle B is congruent to angle C. We're going to prove that the base angles are congruent. So we're going to start out with a given. Triangle ABC is the one thing that you're given, and you know that AB is congruent to AC. So that's given information. Now we're going to bisect this angle. This is a little different. We're going to do a construction, and we're going to create this line segment AD that bisects angle BAC. So in other words, it's going to go straight down the middle right there. Alright, and sometimes when we construct auxiliary lines that weren't really given to us, but we just construct them, we can say construction in the given. Alright, every angle has a bisector, so that's okay. We accept that. Now, step 3, when we bisected that angle, we created angle 1 and angle 2, and we know that they are congruent. Alright, so angle 1 is congruent to angle 2. That's the definition of an angle bisector. Alright, so we know angle 1 is definitely congruent to angle 2, and you can mark those off if you want, just to show that they are congruent. Alright, step 4. AD, oh, I'm sorry, I forgot to put my D on there. There's your D. Line AD is going to be congruent to itself. Congruent to itself. And hopefully by now you know what that is. A little bit of reflexive property. And from that, we know that triangle ABD is congruent to ABD. So I went top and then down, is congruent to ACD. And that is, and if you look, how do I know those two triangles are congruent? Well, this was congruent to itself. I probably should have marked that. I put two little lines there to show that it's congruent to itself. But if you look, you have side, angle, side. Side, angle, side. So that's the side, angle, side property. And then from there, I know that angle B is definitely congruent to angle C, because I have those two triangles are congruent now, so for sure their parts are congruent. C, P, C, P, C. Corresponding parts of congruent triangles are congruent, and that's a therefore. Alright, if you need to see that again, then of course rewind it. Otherwise, we're going to move on. Alright, the base angle theorem. Okay, the base angle theorem says if two angles of a triangle are congruent, then the sides opposite them are congruent. This is the base angle theorem converse, just opposite of what we just did above. Now the two angles are congruent, two base angles are congruent. Then you know the sides opposite are also congruent. Now that's the proof of that is number 26 on page 240. It's going to be part of your homework, so we'll work on that later. Now, turn the page. We're going to talk about a corollary. Remember, a corollary is kind of a spin-off of a theorem. So the spin-off of that theorem is going to be if the triangle is equilateral, then it is equiangular. Alright? If a triangle is equilateral, then it is equiangular. So we have a triangle that's equilateral. We have to prove that all of the angles are equal. Alright, so here we go. First of all, given. Triangle ABC is equilateral. That's given. Number two, since it's equilateral, we know that AB is congruent to BC, which is congruent to AC. Alright, that's just what an equilateral triangle is. So we'll call that definition of equilateral triangle. Alright, now, since we have basically little isosceles triangles in there, I know that angle A has to be congruent to angle C. Angle A has to be congruent to angle C, and angle B has to be congruent to angle C. Angle B is congruent to angle C. Why? Because of the base angle theorem we just proved. Because pretend that's a little isosceles triangle in there. Remember, all equilateral triangles are also isosceles, so that means the base angle theorem applies to that. Alright, so looks like we can do a little bit of transitive. Angle A is congruent to C, B is congruent to C, so therefore angle A is congruent to angle B. And that is transitive. Alright, so step 2 of this theorem, or of this proof, is if ABC is equiangular, and that's given, then we know since they're equiangular that angle A is congruent to angle B, which is congruent to angle C. So that's just, that's number 2, definition of an equiangular triangle. Alright, now I am going to pause the video right there, and I want you to try to fill in the rest of this all by yourself. And actually, I'm not going to pause the video. I'm going to let you try to figure that out, see if you can. And I'm going to go on down here to the next theorem. All right, I want you to see if you can finish this proof out. Do a little research, maybe check your textbook, you know, to see if you can't figure that out, and we'll talk about it in class and see if we can't fill in those steps. Alright guys, I made a last minute change here. I didn't like the way the proof that I had going was laid out, and so I want you to see what I did here. Alright, I took a piece of notebook paper and I just completely covered up this half of the notes page. Yeah, I apologize for doing that, but I think it's best. Like I said, I don't like the way the proof was going, the way that I feel like there were some missing steps in there, and I didn't like it. So I am going to redo that. So I need you to just take a piece of notebook paper. I just cut off a little piece big enough to just cover right over that section. You can see it's like a half sheet, and I'm going to redo this proof here. So I'm going to write statements on here and reasons, and then we're going to go on down here, and I'm going to finish the proof this way. Alright, I do need to add a couple pictures in here. I covered over my pictures, so I'm going to add those in. This is still triangle ABC, and this is going to be hypotenuse leg, so we know those are congruent. Alright, then here's my other triangle. This is triangle DEF, and again, this is the right angle, and we're going to have hypotenuse leg. So you're given those. So we're going to prove that those are congruent triangles. Alright, number one, given. We know that angle C is a right angle. We know that angle DFE is a right angle. Alright, this stuff's given. We also know that line segment AB is congruent to line segment DE. So that's AB here and DE. We are given that BC, line segment BC, is congruent to line segment EF. So I know that this segment is congruent to this one. Alright, so here we go. Number two. Alright, we're going to construct AC so that it is congruent to FG. AC is congruent to FG. So that means we're going to need to construct a G. So I want you to draw a line that looks exactly equal here, so that we have this line segment equal to this one. Alright, now that's going to create a triangle, so let's go ahead and construct EG also, and we can do that. That's okay. You can put extra lines in your proofs if you need to. Alright, that's just a drawing, just a construction. So number three, then, we're going to want to say that EF is perpendicular to DG. So let's look at that. EF is here, perpendicular now to DG. That's just the definition of perpendicular lines. And I can see that I forgot to write construction here, so we'll add that. Alright, if you have perpendicular lines, then what you have is a right angle. So angle EFG is a right angle. Alright, definition of perpendicular lines again. That's what perpendicular lines do. Alright, they create right angles. Now you know that angle C is congruent to angle EFG. Alright, because all right angles are congruent. We know that by the right angle congruence theorem. Alright, so we have, that's this angle right here is congruent to this one. So now we've got those are congruent. Step 6, we know the triangles are congruent. So triangle ABC is congruent to triangle GEF. Alright, and if you look very carefully, we have side, angle, side. Side, angle, side. So the side, angle, side theorem. Now, because the triangles are congruent now, we know that GE is congruent to AB. GE, which is here, is congruent to AB. So that's this triangle is congruent to that one. If those triangles are congruent, then their parts are congruent. So that's CPCTC. Congruent parts of congruent triangles are congruent. Alright. So if those parts are congruent, now if you look back up here just a little ways, GE is equal to AB, and then I believe AB right up here is equal to DE. So do you see these two? AB is equal to DE, and it's also equal to GE. So we know that GE is congruent to DE. And that's a little bit of transitive going on there. Hope you thought of that before I wrote it down. Alright, GE is now equal to DE. That's this one over here. Alright, so now we know that angle D, now if you notice we've got an isosceles triangle here. So angle D we know then has to be congruent to angle G. These two base angles of that triangle have to be congruent. That's the base angle theorem. Base angles theorem, sorry, that's plural. Alright, so now we have the base angles are congruent. We know that angle GFE is congruent to angle DFE by the right, so let's look at that. GFE is congruent to DFE. GFE and DFE, because of the right angle congruence theorem, all right angles are congruent. Congruence theorem. So triangle GEF has to be congruent to triangle DEF. GEF, that's this one, has to be congruent to this triangle. These two triangles right here, I'm sorry, you can't see that very well. These two triangles right here have to be congruent. No doubt about it. Alright, so number 11, that's the angle side theorem. Alright, let's see why that works. Angle side. So, oops, I forgot to mark my picture here. We proved that these two angles were congruent. So angle side. Angle side. Alright, angle side, angle side. So we know these two triangles are definitely congruent. So therefore, now look what you got here. Up here you said down here you said GEF was equal to DEF, but up here you said GEF was equal to ABC. So a little bit of transitive going on here, and we can pull the old switcheroony. So triangle ABC must be congruent to triangle DEF. Therefore, we just proved the triangles were congruent by transitive. And you are probably worn out because that was a long proof. Alright, I hope you got that down. Feel free to go back over that proof again if you need to, just to kind of piece that all together. Maybe you were writing too much and not doing very much thinking. So it might be worth going over again. And that's pretty much it for this lesson. We will see you in class